I'm so far away.
Okay, we're going to need to put a few slides up first, but hopefully this is all just going to work.
You can just move it over, yeah.
Um,
Yeah. Perfect. Mm-hmm.
yeah.
Yeah, it has got batteries.
Starting.
Testing, testing, testing. This one's really hot. Testing, 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 testing. Check, check, check. Check, check, check. Check. Okay. Whoops. It's a very.
So it starts at 9, right?
Hey. Yeah. Cool. I would just tweet it. Yeah, tweet it out. Okay. Yeah.
For the summit, yeah.
I think I'm gonna up with you if that's all right. Don't, let's get that seat. Hello. We got everyone? Oh, I didn't want to anyway. All right, good morning. Welcome to day number 2 of a huge amount of excitement and anticipation. Have we still got me there? Yeah, that's all right. How we go? I talk like that with a stiff neck. Great day ahead of us today. Thanks, Ricardo, giving me the evil eye and message. I guess we've lost a few from last night. The reception did kick on. It was pretty good. I know a few people went out and had a bit of a late night afterwards. I ended up with George at a Ukrainian restaurant, which was a new experience for me. The way that Simon hooked into his borscht, I'd say it's a new experience for him as well. We do have some details just to cover. We've asked for the air conditioning. Too many people were just getting down into their shirts. We thought that was a little too comfortable for Canada, so we've asked them to turn up the air conditioning, especially when we divide that room. Apparently it was getting a little bit like a sauna. People were starting to strip down to bra and panties, and we thought that's probably not appropriate given we had a camera running around. We don't want to send the wrong message first thing in the morning. The dinner tonight. So I believe a lot of people had, all co-workers and friends all do their registration, so they've got no idea whether or not we're coming. So I have no idea whether or not you're coming, but I hope you are. We have a lot of people coming. It's fun and frivolity. George, and he's going to have an offsider. I think it's Nagan's now volunteered to do the emceeing all night. Fun prizes and giveaways, and I definitely will have a small 3-year-old child running underneath your feet. Please do not tread on him. You'll hear the scream. It will be at the Vancouver Aquarium, which is literally take a lovely walk around the seawall. And you're loving those umbrellas now, aren't you? Yeah, so there was giggles when you first got it, but now you see the reality. Walk around the seawall, and it's about 10 minutes. I believe Phil Chatham, right in the middle there from UBC, has nominated himself to hold up the LAK umbrella, so he's unique, and lead the way. Once you get there, we will just sign you off and we'll give you a couple more drink tickets. It seems to loosen everyone up a little bit more, and you seem a lot more relaxed after 2 drinks, if the reception is any indication. So you'll grab that there and then just hook in, have fun. There'll be food being passed around all night. I believe Al Esser is going to do a presentation down on the dolphin show. If he's got his flippers on, fins on, he will be able to swim with them and stand on the back of 2 dolphins. Al has been practicing a backwards somersault as the dolphin somersault and trying to land on. I'm a little bit worried about the fins and where they're going to land with Al. Keep your legs together, mate. You'll be right. Other than that, I think we're pretty good to go. So if anyone has any more questions, thank you. We're going to have a great day. Dragan and Simon are going to, Simon and George are going to talk a little bit about solar and where we're up to next in the AGM. Thank you very much.
Well, good morning. Hope everyone's enjoying the conference as much as I am, and certainly one of the best parts of these events where you bring together folks from many different disciplines is the opportunity to bump into random conversations in the hallway and start to realize that you are not alone in your institution. There are others in different universities and systems that are doing some amazing things around analytics. I was particularly struck by, a variety of Barry's comments yesterday, but one in particular, which was that he saw some parallels with where we are with this learning analytics community and what he experienced in the 70s as he was looking at putting together the social network analysis field. And the parallels of the energy and the innovation and the camaraderie that existed in that was one that he paralleled here. So I find that to be an encouraging statement, simply based on the huge impact that social network analysis now has in many aspects of organization, society, and increasingly learning. A couple things I want to reference today, though. Last year, after we held our conference in Banff, it was beautiful and sunny and very lovely and not cold at all, we ended up with a post-conference meeting where we talked about really, is this a field, what might we want to do, and where might we want to go as things move forward. And a few things came out of that, and we've tried quite hard from Solar's perspective at least to not be prescriptive. We've really wanted to emphasize that if individuals have a passion or interest and enthusiasm and want to do something, we want to highlight people that are interested in participating with what Solar is doing, and we want to highlight initiatives that others are engaged in. So we don't want to prescribe everything, but there's a few things that I think we're increasingly excited about, and we've worked on this really since the last year, and there's two points to reference. One is solar flare and solar storm. You may see where we're going with this. Solar flare initially was Solar X, but then we figured, with TEDx and MITx, the X was being abused. So what solar flare is essentially a series of regional conferences or regional sessions, summits, if you will, that'll be starting in different parts of the world, really October 1st to 3rd, I believe, is when Purdue will be hosting a learning analytics event. There's also an event that is being planned for Australia and another event that's being planned in UK as well. So that's an attempt for us to say, last time we met a year ago, we were talking about analytics at a certain level, and then you meet a year later, and it's almost like the field has completely changed in many levels, and that there's too much of a time space between those conversations. So it's just the opportunity for people to connect with more of a practitioner emphasis. So it's not necessarily the full research paper, but it's more about talking, what are we doing, what's innovative, what's having an impact, what am I excited about, what are early stage research ideas that you may be able to incorporate in some of your own thinking. The second project is one that maybe won't have as broad an interest here, but it's what we're calling Solar Storm, which is essentially a distributed research lab. And this distributed research lab has really 3 key research areas of interest. If you go to the Solar Research site, you'll get it briefly listed there. We'll be posting more information shortly. But we're targeting research that looks at social media and networks on the first level, second level, analytics and data, and then on the third level, the impact and the potential structural changes in terms of the educational model. What we've done with this is it's a multi-year initiative. We have a series of advisors. We'll post their information on the site shortly that are sort of overseeing this, folks that you've probably met, Terry Anderson, who is at the conference here. We also have Tom Reeves. We have Jan Harrington. I mean, the list goes on. I'm missing many of them. Simon Buckingham-Shum and others. So those are the advisors who sort of serve to provide guidance and direction as we're developing this distributed research lab. And the reason I should present a little bit of a background, the internet has changed how we produce and create content. It's starting to, under the terminology of Udacity and Coursera and MITx, it's starting to change how we think about teaching. What does the technology and the continual connectedness of our society today, how does that impact teaching? And what we're really doing with this is, what does the internet do to research? How does it influence how we research, and do we need these geographical research labs to advance a field? So we have the advisor board there. Then we have the second group, which is essentially research leads. And if you have a particularly provocative research question, analytics, or the 3 topic areas I listed, come chat with us later. We're certainly, this isn't fixed in stone. We're looking for advisors and researchers to still join on. And then the third area is what we're looking at for doctoral students or postdocs or research students, let's say at a master's level, that have a particularly provocative area of research that is relevant to advancing learning analytics. So that's Solar Storm. Distributed research labs will be meeting monthly online. You're still going to function under your existing advisor role within a university if you come in as a student, but it'll give you an opportunity to connect globally with people who may have complementary skill sets. So if you're more into social pedagogical models, you'll find someone who's strongly potentially into analysis and more of a mathematical or technical view. Information's on the site. Any questions, approach any of the Solar members on this as well. Thank you.
Okay.
The next thing we want to update you on as part of what Solar is doing is Learning Analytics, the journal. So this is Solar's official journal. We feel that the field is ready for something like this, longer contributions, a place to really establish the roots of the field. Many people aren't aware that many tributaries have flowed into the creation of what we're currently calling learning analytics. We don't want to be reinventing the wheel. Many lessons have already been learnt from intelligent tutoring systems and user modeling and et cetera, et cetera. In a minute we're going to hear from Kati about visualization. There's much to learn from many other fields. So the journal is a place to do this. Up here we've got Phil Long from Queensland. Dragan you already know. So we sort of represent the education, computation, sense-making sort of triad that we feel the journal needs to try and bring together. Okay, doesn't really need a lot of explanation, and on the website you'll see what some of the topics under these three headings. Education, obviously, that's what we're here for. Computation, we wouldn't exist without computation, and sense-making, because the cognitive, collective, organizational, ethical deliberations about what one does with this stuff is far from non-trivial. So those three are sort of loosely represented by the three of us here. The way we're thinking about this, obviously this will be a peer-reviewed publication. It will be indexed, etc., in the right places. It will be open access, free, and we're trying to innovate a little bit on that front. Journals and conference synergy. Dragan, say a little bit about that idea.
Right. For me, coming from the computation side of our community, basically we have a kind of a common practice that we have a life cycle of publishing. First, going to a conference, get a paper peer-reviewed there, and then extend it and basically kind of add additional 25-30% of contributions and publish it in a journal. But that's not really that common for other two important parts of the community, which is education and sense-making, where basically people are not really used to having these kind of high bars to enter conferences, to even have published conference papers. Rather, there are just quick reviews of their abstracts and they come to talk. So our idea is basically to try to innovate there by basically encouraging educators to contribute directly to the journal, full papers, and then those papers then to be invited to the conference, Learning Analytics Conference, to be presented. In that way, we basically make sure that we are always having balanced program on one hand, and the other hand, we basically also are trying to avoid this kind of a problem of double publishing. Phil?
So the one area we realize this is a new journal and such, and we want to have the journal be credible and useful, which means it has to earn an impact factor that matters to many of us in areas where that goes with the territory, and which allows us to petition to our institutions to fund our travel and such. At the same time, we're also very interested in open scholarship and new models of sharing and publishing. So we'd be very interested in getting feedback and ideas from all of you about how we can match these two things together. The journal itself will be open access and the like, and therefore more formal and conventional in some aspects of the scholarly process. Alongside of that, we're very interested in some mechanism to host open publishing, the sharing of manuscripts or papers in draft, a mechanism for the community commentary around that, and the possible advancing of paper discussions that emerge in that context into the more formal journal publishing stream. As a community activity. You'll see some of these things going on in a lot of innovative experiments around publishing, and Solar wishes to be part of a contributor to that innovative community as well.
Okay, and the final point to make is that we are now thinking about what the inaugural issue should be, to be sort of drawn from an invited selection of papers from the last two, well, this conference and last year's, and perhaps some additional invited contributions. So watch this space. Obviously, we're also putting the editorial board together as well right now. Okay, so Solar Storm, Solar Flare, and the journal, all part of trying to create a new research community, but one hopefully which is going to be able to be agile and responsive to the very fast changing world out there as well. Okay, thanks very much. Okay, Kati, should we just get your machine up and running here? Okay, so this brings us to the first main event for today, and it's clear that we have huge amounts of data becoming available, and we have computation to thank for that. Sorry, I'm just going to stop for Kati. I think we're running the video feed on your machine here. I'm hearing it echo back. Just wait a minute. Can I have a tech guy here, please? Something weird happening here. This is echoing back here. What's going on? No. That's the demo video.
This one here? Oh,
Yeah, this one. So I'm
Okay.
hearing myself talk back at myself. Which is not
And
good.
the PowerPoint, right?
Okay, here we go. All right. Okay, so computation is giving us huge amounts of data. But for this to become meaningful, actionable insight, we also need computation to support the sense making. And that's the design of human-computer systems to give form to and share and debate our interpretations of what these dashboards are telling us. As we've already seen from our workshops and the papers just yesterday, many of us are experimenting with interactive visual analytics as a way to represent and manipulate artificial representations of data. So it's with great pleasure that I want to introduce Kati Borna. Kati is Professor of Information Science at Indiana University, where she leads the Information Visualization Lab, and where she was the founding director of the Cyber Infrastructure for Network Science Center. Now, Kati is unquestionably one of the world's leading information visualization researchers, judging by her work, at the highest levels of scientific academic activity. But in my view, she's actually the world's leading researcher when you consider the passion and energy she's putting into making her field accessible to society, and the energy and effort she's putting into creating information visualization tools that aren't just amazing state-of-the-art things that run in a lab, but the energy she puts into creating robust tools that are out there in use by thousands of people, hundreds of thousands of people, in a usable form. And I think there's a real lesson there for us to think about. That's a transition from research to practice that's a real model for us. So it's no surprise that this year she became a fellow of the American Association for the Advancement of Science. She keynotes all over the world and across many disciplines as well, which is another model for us. And so, I was absolutely delighted when she responded very quickly to our invitation to come and speak to us today. So please can you welcome Kati, who's going to talk to us on visual analytics in support of education. Kati.
Thank you. Interesting. Okay.
Where's your volume?
It's interesting. Let me actually kill it because it probably. I think it's all done. Okay.
Okay.
Thank you. Good morning, ladies and gentlemen. It's a true pleasure to be here, and I hope to learn more about what data and what questions you have as this day unfolds, and hopefully you get interested to play with some of the tools I brought you here. The talk is divided into 3 parts. One is a more motivational overview of some of the works we have done in the educational area, but also with some pointers to what might be possible in the near future. The second part is a tiny bit of theory, just given the time I have here in the talk, but hopefully you get interested to read up on some of the many formulas behind some of the algorithms, some of the technicalities of how certain tools are implemented, etc. And then finally, maybe most importantly, I wanted to leave you with some tools which you can use to start analyzing your own data. And I will be around all day, so if you have data and if you have a question, please feel free to find me, and we can look at your data. The first example in this first part of the talk is on trying to monitor and evaluate what's going on in 3D worlds. And this is work we did about 10 years ago, and back then you didn't have very extensive tracking in real-world environments. However, you had 3D virtual environments such as Active World and now Second Life, which allowed you in a very, very detailed way to track what people were doing there. And given all this data, you can then go about trying to, first of all, try to understand what kind of spatial, topical, and social navigation is going on, but then also trying to support this kind of navigation, which people do in their foraging activity, in their social networking activity, etc. Ultimately, you want to use this expertise and this knowledge to design learning environments that really works, that don't have bottlenecks, that lead to fruitful, encouraging and empowering learning expertise and environments. How many of you have used Active World technology? There's one arm, 2. All right. What about Second Life? All right. How many of you have GPS-enabled devices with you? Wow, look at this difference. So there were very few arms for the first, a few more for the second, and so many more for now, actually giving you access to almost the same data which existed only in these virtual worlds 3 years ago. So let me tell you what we did for a conference, and I thought this is appropriate because you're currently attending a conference. And assume you would be tracked in a very detailed way. Your position in space would be tracked. It would even be tracked what you tweet about or what you text to each other. We would also know what kind of resources you access. In these 3D virtual worlds, you could click on web links, you could teleport. Can't really do this here, sorry. You could also find out who is in your vicinity, who is kind of able to overhear what you talk about, and then you can map this on. This particular conference I'm talking about is the We Learn 3D conference, which took place over 7 hours in a 3D virtual world in December 2002. And as you see, and I don't have a, maybe I can go over and show you here. Is the microphone on? Maybe I should stay here. Let me try to use the mouse pointer. So this is the center world. This is ground zero. This is where everybody starts. Some of you have designed online portals, so everybody would come in through this portal. So you can also kind of try to make the leap to 2D websites if you like. But we are here in a 3D world. And particularly, you come in here. The first world has a number of breakout sessions and talks going on. Then you have more talks over here on interactivity and new avatars for science and guidance. And then there were 5 breakout sessions. And as you see, all these worlds are squares, just like this room is square. So again, I think you could very nicely find analogies of how to map a real-world conference. After those 5 real-world virtual world breakout sessions were over, we all came back to a closing ceremony with a real virtual firework, which was very beautifully done, and then we dispersed. What you see here now is color-coded trajectories of people in this space, and color coding happens according to the 7, actually there was 1 hour before the conference where people already gathered in the world. So altogether 8 hours of activity in this world. If you're interested to see how you actually have talks in such a world, you have a stage, you have 3 display walls, and so you see here a talk which talked about having 3D online worlds where people learn, and then having mirror worlds which kind of reflect upon what is happening in these 3D learning environments. And people gather around there, and you can enter queries and questions via chat, text, etc. The reason for having it in a virtual world was mostly depending on finances. Many classroom teachers don't have the resources to come to Vancouver, or they can't take off from actually doing their daily teaching, but this was done at a weekend day, so it's actually very doable then for teachers to join such a conference. Each world, I already mentioned, is a square, and you can then overlay the trajectories of people roaming through these environments. Whenever people just stand there, they grow these kind of idle circles, which get larger and larger over time. You can also identify what kind of buildings exist in this world. These are the greenish elements here. You can identify what teleports, what web links exist, and you can map this over time and then try to identify what actually happens in those worlds. So again, these are the different worlds with kind of screenshots of how these worlds look like, and the kind of color coding for the different activities. We then use this mapping technology in the Quest Atlantis world. How many of you are familiar with Quest Atlantis? So Sasha Barup and many of his colleagues, they developed an online learning environments, working very closely with Active World to try to get children interested in math and science and technology education after school. So they really saw this as a game. The Active World technology and Quest Atlantis was also deployed in boys and girls clubs. And some of the kids there couldn't read and write, and they kind of dragged people over because they really wanted to interact with people in those virtual environments. So I think it's a huge motivational effect also for getting children interested in all kinds of different science, math, education activities. Now, if you have a 3D virtual environment, you don't really immediately see all the people in front of you. It's actually very hard to make sense of a 100-people team or even 20 people. You might have students which accidentally click on a teleport and they are off, and you have to kind of retrieve them again. Or you would like to understand if they really went through a certain learning experience, or if they just overheard the answer by another team and then sell it as their own. So you really want to understand what they do in these worlds and in how far they go through the learning experience you develop for them. We were also interested in group dynamics. We wanted to understand if people which stick together learn better, or if it's better if they go out and develop understanding on their own and then come back together to discuss it. So in another piece of work, we looked at spatial proximity and semantic coherence. So here you have different groups of 2 people traveling in these worlds together, and these are very specific worlds where you have a knowledge landscape depicted. And you will see a screenshot in a second. And we wanted to know when, where, and why users interact when they explore such an information space. And ultimately, this is very important for designing these information spaces because you want to, again, support spatial navigation through this spatial space, semantic or topical navigation, helping them to find certain resources, and also social navigation, helping them to understand who has what expertise. Maybe they can partner. If they have to do work in teams, you might like them to build useful teams, which have complementary expertise, for instance. So here you see some of the visualization spaces. It's an visualization environment where you have different papers connected via linkages, and you also know which ones are how well cited in this environment. And then in the Active World browser, you can chat with each other. You can also click on the citation sticks here, and you get to know what paper you're looking at and when it was cited, how often. So this is a very specialized world, maybe too specialized for K-12 education. However, what you can do in these environments is you can track what people are doing. You can find out what they are talking about and in how far the topics they are dealing with correspond to the space in which they are operating. You can, of course, also, again, track their trajectories. So these are different groups trying to explore this space. And you can interlink the space and the semantic chat logs and bring them all in one interface, in one visualization. So here you have different chat sequences. You know time elapsed, so you see that they started in the middle of the world again, and then they move around in that world talking to each other. And this is one group, and you can also do look at another group where you then get to see that actually here people split off and they worked on their own and then came back together and talked with each other. In the interest of time, I just provide links to the paper here. So if you're working in environments where you would like people to explore spatial, semantic, and social navigation, you might like to look at this work and try to monitor in detail what people are trying to do and then support it in a more effective way. The second example I prepared here is an attempt to teach children an holistic understanding of science. As you might know, many classrooms have a map of the world on the wall. And this is for a good reason, even though many kids might never see all the many places on our planet. It is useful for them to have an understanding of the whole and also to have an understanding that you now can take all kinds of different data, political data, resource data, war data, news data, Twitter data, and overlay it on that base map of the world. And we were interested to teach children the base map of science so that they can also get a better understanding of all the many topics they are learning and how they interrelate with each other. So this is actually part of the Mapping Science exhibit, which some of you might have seen in real. This is an effort over 10 years to educate the general audience so that you can map science using scientific means, using terabytes of papers, patents, grants, large-scale computing infrastructures, and advanced algorithms that scale to millions of nodes and records to get a more holistic understanding of the structure and dynamics of science. And what you also have in the exhibit are these two puzzle maps. These are SLIKE and SEEK puzzles where you have a map of the world and a map of science, and you're supposed to overlay and find the right spots for major inventions and inventors. The exhibit also travels in trains, and what you see here is an so-called illuminated diagram display where you actually see a map of the world, and overlaid here are activity patterns of different types of scientific activities, and so you can zoom into them. The illuminated diagram is actually a combination of high-resolution print, 300 dpi printouts on transparencies, glued on to either backlit projectors like here, or you can also have a large-scale printout, 3 meter by 3 meter if you have the space, and a projector, which then does the interactivity of different data overlays. So here in the attractor mode, you have a map of science, and you have this line going over it, and whenever one of the 554 subdisciplines of science is hit by this line, then you see highlight in the map of the world who is conducting this kind of research. However, you can also use the touch panel display to select certain areas of science. And again, you will see highlight in the map of the world who is working on those topics. What are the centers of activity on that kind of science? You can click on obesity or cloning. And again, in both maps, you would get to see who's conducting this kind of research where. And then we also have some Nobel laureates, and you can see their impact on both landscapes. So it's a highly interactive display. Going back to the presentation, this was also deployed in a train. Trains are a great way to bring a lot of science quickly to many people. You have to be a little bit careful when designing such a train. Basically, nothing can be really too interesting because then people don't go on anymore. So you basically enter the train at the end and you come out in the front. And so if there's something which kind of creates a bottleneck, that's bad. But if you manage to do it well, then you can really communicate a lot of science to many people. And so this particular train made it to 62 cities in 7 months. So try to get a train, try to get a science train. So what we did to bring these science maps to children is we took the real maps, the real data. We didn't try to hide the data, but we overlaid watercolor paintings which you see here, to make it more tangible for children. And then, as I mentioned before, you have these puzzle pieces, and you have then a kind of slide and seek puzzle setup, where you now have to try to identify the right spots for those 18 inventors and the 18 inventions. And it's interesting to note that if you open a science technology book for children in Europe, you get a lot of European inventions and inventors. If you do this in the US, you get many US inventions, inventors. I'm not sure about Asia, but it's actually non-trivial to equally distribute and intelligently distribute these kind of inventions, inventors over the map. So it might even be hard for adults to do this correctly. We did the same for the science map. So here you have a map of the world. And again, you have the same 18 inventors and 18 inventions. And now, good luck trying to get them to the right places. So this is the installation in the Monroe County Public Library in Bloomington, Indiana. But it went to many science museums and public libraries also. We also took those science maps into classroom settings, trying to communicate to children that there are maps of the world, and you can use them to track the trajectories, for instance, of Columbus on those maps. And then there are science maps which you can use to track trajectories, career trajectories of scientists over the landscape of science. And children seem to think this is just very normal, that you have those two maps and you can use them both to do very similar activities. We had very interesting discussions surrounding some of the key scientists they knew, such as Albert Einstein, who has made major contributions to multiple areas of science. So where would you put him? Would you put him in his main area of contribution, but which one is it? Do you chop him up in 3 pieces and put him in 3 areas? Do you kind of try to find the middle point of all of his contributions, but there might be no island, there might be just emptiness. So what does it actually mean to have emptiness on those maps? Very interesting. And then we tried to also find out what these children, this is the second class classroom, what they thought they might be doing in science. And one of the 7-year-olds, she stood up and she said, I want to be a nuclear physicist. And then she took her little star and put it right in that area, which was very touching. We also have a number of coloring exercises which come with the exhibit. And ideally, children get a much more holistic understanding, but also a more tangible understanding of the landscape of science. It's not as abstract and nebulous anymore, which it is for many children and adults today. I should also mention that this year's iteration of the exhibit is all on science maps for kids. This is the call for maps. The maps are in production mode right now. They are going to debut in July. So if you're interested to see how these maps which were submitted can be used in classroom settings, watch out for the news items on the release of those maps. If you ever get interested to have the maps on display at your institution, or if you know a science museum close by to you, which would benefit from having the exhibit, we're always on the lookout for good venues, but be aware it comes in big crates, and you will be very familiar with the height of loading decks, and you will have on speed dial people you might not have had on those speed dial buttons before, etc. So it's a very different enterprise. The third example, maybe very quickly, is an attempt to bring some of the tools, which you will see very soon, into classroom settings and government agencies. And I'm not equating kids and government stuff here. I think they have very different needs and very different expertise to bring to the table. But I'm not bringing these tools to another computer science department. I'm not bringing them to another ivory tower. I'm really trying to bring them into the hands of people which typically might use PowerPoint and Excel and tools like this, but they don't really do network analysis right now or burst detection, etc. And the questions which I have, and maybe you have answers, I don't have those answers right now, but I would be very interested to understand what you know about it, is how do people actually make sense of big data or small data in their daily lives? How do they use data analysis? How do they consume and interpret new and existing visualizations. Can they read network layouts? Many can't. They have never learned this in school, and they might have seen some smaller networks in the news media. But they have a very hard time if you show them a large network with a backbone and community structures. And do they use any visual analytics tools or visualizations? What do they use? What's their favorite visualization? And all this has as a goal to empower people to have fun in their life with big data and with tools, but also to then identify patterns, trends, and outliers in their own data, ideally first, but then also in other data, and then make effective arguments, really use data to have more objective decision-making skills. So what we did was to go to classroom settings and to use Google Trends, for instance, or Gapminder and Wordle to help them answer when, where, and what questions. And I typed in this morning learning and analytics, and it's kind of a shame to see learning going down, especially over Christmas. You might see this. Analytics seems to be going up. Learning analytics doesn't have enough traffic to have any trajectory yet. So it's interesting. I think these are interesting indicators. How many of you use Gapminder? All right, you might like the other ones, which didn't lift up raise their arms. You might like to explore it also. So these are visualizations which I think even children in classroom settings can understand. And they typed in hamburger and cheeseburger, and they typed in pizza versus spaghetti. So they used different examples. They did not type in learning and analytics, but I think it's interesting for them to understand that you can now start analyzing this kind of data. And I will come back how we do the introduction to tools to government agency later. All right, tiny bit of theory. So in my world, and maybe also in your world, this is the general process which we are going through. So we have a stakeholder group up here, and I will use my mouse pointer to point this out. And we do a very serious needs analysis with them. We would need to understand what do they get hired for, what do they get fired for. So we really want to understand what drives them and what makes them most productive, and what are the priorities in what they need to understand. Next, we need to understand what data they have. If they don't have any data, we can't help them analyze this data or visualize this data. If they have no data, we might be able to help them to set up a process, online forms for instance, that gets them the data that after a few years of data acquisition, you can then use to acquire certain insights. All right, let's assume we have a stakeholder group which actually has data. Then it would be a matter of setting up a certain workflow that helps them analyze this data and visualize it. So here you would go from data acquisition. So you try to get your hands on the best data out there, highest quality, highest coverage, as much data as your budget allows, and also resources. There's always time involvement also to actually get access to data. Then you would pre-process this data. You would clean it, you would unify it, you would interlink it with other data, you would geocode if you want geomaps. You might like to extract networks if this is relevant for the questions your stakeholders have. So this is all pre-processing. And to be honest, you will spend about 80% of the entire project time on just this, so just pre-processing. So if you don't like cleaning data, go somewhere else. It's just what it is. You have to clean that data, because if you don't clean it, everything else is not going to be very meaningful. Next, you would do some data mining. Could be very simple. Might be just extracting a backbone for your network, or doing simple trend detection. So looking for sudden increases in usage frequency in words, keywords used in your data. Email streams, Twitter streams. You have one keyword, LAK 12, and you want to know what bursts of activity exist in that stream. And then you want to lay out your plot, your network, your geomap, etc. So this is all very serial. So you have data, you do something to the data, you have more data, you have additional columns, you might have cleaner data, etc. So it's very, very serial. And then you encounter something that is inherently parallel, and that's why it's so hard. And this is the design of visualizations that are meaningful and that are easy to use and simple. And here you would have these different steps. One is that you have to find out what kind of reference system can your stakeholders read. Timelines are good, scatter plots are good, geomaps are good, because you have learned this in school. Networks are tricky. You have not learned to read those in school. So be careful what you use here. Circular layouts are also, I believe, very tricky for people to read. Next, you might need to do projections, distortions. So if you have a 3D map, for instance, of the world, you oftentimes don't want to give them a globe, but you want to give them a 2D map. So you have to find a projection that projects your 3D surface of a sphere onto 2D. So that's one projection, and you could go for equal area maps or distance preserving maps, etc. So that very much depends on your insight need. In scatter plots, you might like to have a logarithmic scale. That's also a different type of projection distortion. In the third layer here, you overlay your raw data on the geomap, in the scatter plot, etc. And this will show you certain density patterns and will give you a first feel of your data. If you have a timeline and there is just nothing for a few years, you will immediately know that you're missing data, and you have to go back to your stakeholders, get the new data, go through all the analysis again, and then go on in your visualization efforts. The next layer here is graphic design. This is where all the color, shape, size, and other coding happens. So ideally, you have a graphic designer there, or an art student or artist, who helps you to not only identify the best type fonts, but also good color schemes, etc. Oftentimes, your data is large, so you need to aggregate and cluster it. And again, you could do this via color coding, or you introduce additional graphic elements, such as boundaries, which go around certain clusters which you have in your data. In many cases, you want to have different views of your data. You could use small multiples, small views of your data, many, many different ones of them, just giving you quick profiles of your data. Or you might have just 3 windows into your data. One might be a quick timeline. One might be a geomap and a science map. And ideally, these are coupled windows, so that if you click on any item, any record in the timeline, for instance, it would also highlight in the geomap and in the topical map. Next, you would like to most likely interact with your data. You want to search, you want to filter, you want to retrieve details on demand, you want to click on that record and actually end up in front of the tweet or in front of the blog entry or in front of the course syllabi of that one course. In many cases, then, you also want a legend. You want to have a title for your visualization. You want to have information on what kind of size and shape and color coding you did. You might not have to sign your maps in blood, but you might like to leave some indication of who did this map so that they can complain or provide advice or ask you to consult for them and make money, etc. So find a way that they can get back to you, especially. Actually, you should only put stuff out which you're proud of. If you're not proud of, then you might be more tempted not to put your name on it. But just do visualizations that matter to you and to your stakeholders and proudly sign them, just like the old map makers all signed their maps. And finally, deployment. As you might realize, it makes a huge difference if you are designing for a handheld device with very small number of pixels, or for a large display wall, which might be as large as that entire wall over there, or design for printouts on paper, which have much higher print resolution quality, and you can pack a lot more information in a square meter than you could possibly do it even with the best, highest resolution monitors out there. Now, the problem is, depending on what you select, for instance, for deployment, you might not be able to pack so much data. You might not be able to have certain interactivity. You might not be able to have certain types of interactivity. So this all interacts. And if you have designed visualizations, it's very healthy to actually start dissecting them and trying to figure out what you did in every single step of your process. And ultimately, You're also now using results from, for instance, your analysis process, and you use clustering results, which you did down here, in your aggregation clustering step. So there's also a tight coupling between what you do in the analysis phase and the visualization phase. And ultimately, you bring back your really impressive visualization to your stakeholders, and they might have no idea what this is, or they have no use for it in their daily lives. So it's very much a very iterative cycle here. When I started doing this research, the different types of algorithms which you need to make it through workflows that potentially have 12 different algorithms involved, these algorithms, they're written in C, in Fortran, in Java, and you name it. In many cases, the output of one algorithm doesn't fit the input format of the next algorithm. So if you use 12 algorithms, you might have 12 minus 1, 11 converters in between all of those algorithms, making it very, very time consuming to make it through this once. And then it's not much easier and faster to make it to a good visualization. So we started to do tools which basically support different types of analysis. So one type of analysis is statistical analysis and profiling. Another type of analysis, temporal analysis, really answering when questions. Then there is geospatial analysis, which helps you to answer where questions, so where do things happen. And there's also topical analysis, aiming to answer what questions, and network analysis, with whom questions. These types of questions occur at different levels. They might occur at the micro level, so just single individuals and their career trajectories, for instance, or one student and the many courses he or she takes, and where he or she is coming from and what she's going to do next in her career or his career. It might be at the meso level or local level, an entire department and all their teaching and how it relates to other teaching on campus, for instance. And at the global level, looking at education in a global sense, and I think that is more and more necessary today, where you have brain drains all around the globe and also reversing ones. So here I don't have examples for you which come directly out of the education domain. Instead, I have examples of science, technology, structure and dynamics studies. And hopefully you can make the leap to some of the data you might have. So in one study, we were asked to identify and map Indiana's intellectual space. So this is Bloomington, Indiana, where Indiana University is. Indianapolis, where the airport is, and then Lafayette, where Purdue University is. And in this particular case, we had proposal and funding data for the state of Indiana in the biomedical domain, and covering industry-academic relationships. So every single proposal had to have industry and academic partners. You can use this data set to identify pockets of innovation, so where do new ideas get born, and then also how do those ideas make it into products. And ultimately, our clients also wanted to understand the interplay of industry and academia. And so here the color coding used is very simple. You have red for academic and yellow for industry, and then academic to academic is connected via red linkages, and academic industry via orange, because that's the mixture color of red and yellow, and then industry is yellow. And this was a flash animation which you could animate over time. You could click into certain nodes. You could get to see the listing of all the proposals and all the awarded grants. You could sort it by lead PI. You can sort it by dollar amount requested or awarded, etc. I believe you can do similar maps for some of the data you might have in terms of students and how they go from one institution to the next, in terms of research that gets conducted in the education domain, and I have some of those maps later on for you, and also in terms of industry-academic partnerships that already exist in your emerging space. What you can also do is to animate these kind of networks. So here you have a network of information visualization researchers. It covers one conference out of 3, no books, no journals. Each node here represents a researcher, so each node is labeled by the last name of this researcher. And as time goes on, you see nodes grow as people publish more and more papers. And actually for the LAK conference, I highly recommend that you keep good track of all these papers and animate them to your 10th anniversary in a similar fashion. And you also get to see that we did some color coding here according to the number of citations received. So what you want is a large node which is dark, highly cited. You also see that there are some nodes which are large and not very dark. And it could be that these people published and nobody cared, or it could be that they recently published a lot, like John Stasko here at Georgia Tech, who is one of my heroes. He was just really productive very recently, and really nobody had a chance to cite those papers. You also see that many of those networks are unconnected. For instance, here Virginia Tech is very much on its own. Berkeley is on its own, etc. And this is very normal because oftentimes researchers work with their student sets, and if they have a many author paper, it's a fully connected clique. And then you have some weak linkages, like Stephen Ike worked at Xerox PARC and CMU. And you see that networks that grow in research labs, such as Xerox PARC and Ed Robertson and Stu Card and Jack McKinley, for most of what this data set captures, actually work together in this environment. This doesn't happen at a university. Typically, each university has exactly one information visualization researcher. And that researcher, like Ben Schneiderman, would work with an incoming, outgoing stream of students. And what is also interesting then to understand is really how these networks evolve over time. And again, I think it's interesting not only to do this for publication data, but also for funding data. So who is co-PIing with whom? To do this for patent data, who has patents with whom, and so on. In another piece of work, we wanted to understand the impact of the internet on the importance of space. So does space still matter in the internet age? Do you still have to be at MIT, Harvard, etc., to do most impactful work and be connected to the right crowd of people, etc.? And so what we used here is a 20-year data set of PNAS publications. So it's mostly biomedical publications. And here you see a map of the US, and these citation sticks indicate how many citations go to what institution. So Harvard clearly sticks out of the crowd with enormous number of citations to its work. What you see down in the lower right is maybe more relevant for answering the questions. Here you have plotted the log over the geographic distance on the x-axis and the log of the number of institutions citing each other on the y-axis. And I would have expected that as the internet comes into existence, this curve would flatten. You would actually see more institutions citing over longer distances. What seems to happen, however, is that the curve gets steeper and steeper as time passes. And we didn't really have a good explanation, but Barry Wellman, who gave the keynote yesterday, and a colleague of mine, Howard White at Drexel University, they, around the same time, published work where they also looked at a similar phenomenon. And they concluded that as we are bombarded with more and more information, we actually use our social networks, our scholarly networks, in a more extensive way to also help us decide what should be listed in the list of references at the end of your paper. And ultimately, we also maybe take into account whom we have to face in the hallway again, or at the next conference, and that might also have some impact. So we might read more, but the citations are not more global yet. In recent work, we work very closely with funding agencies. Here, the National Institutes of Health, and we look at the, you could almost call it return on investment, but it's not totally correct. So here you have data where you have funding data, but also publication data, and both are linked. So NSF and NIH now have found a way to interlink the funding they give out to the publications that acknowledge that funding. And what you can then do is you can look at our one investigator-initiated research, for instance, here on the left-hand side, and you can look also at large center funding, and all this funding which you see here is on tobacco research centers, kind of same time frame of funding, not exactly the same dollar amount. You have this little graph up here, but same topic areas. And you see that the networks that evolve out of the center funding look very, very different compared to those which come from the R1 investigator-initiated research. So these are publication co-authorship networks, and different R1s have different colors here. And similarly here, different centers have different colors. So very different structures. And if you're interested in fast information diffusion, then obviously a network which is denser connected and more holistically connected is more easy to diffuse information in than a network that is highly dispersed. In other work, we look at topical trends. So here we use the same 20-year PNAS data set I mentioned before to identify 50 terms that are widely used and that also experience a sudden increase in usage frequency in those 20 years. And we did this only for the top 10% most highly cited publications. So here each node represents one of those 50 terms and is labeled by it. The circle size corresponds to the burst weight, how sudden an increase of usage frequency that term experienced. The circle color is the burst onset, the year in which that burst came into existence. And the ring color is the year of the maximum word count. Given the color code on the right-hand side, you also get to see that the greener, lighter yellow colors are earlier years, and the red and black colors are the later years. And you see that typically you have the burst first and then the widespread usage. And it would be really interesting to now fold in the years 2002 to 2010, for instance, or 2011 if you have the complete data yet, and see if really growth and protein and models have been experiencing wide stream usage. And I think there is a certain prediction and predictability in this kind of work. So I think there is normal science which can be predicted to a certain degree, and then there are revolutions in science and external events and stimulus funding and so on, which is much harder to predict. If you got interested to have more information on the algorithms applied and the formulas behind this kind of research, there are a number of special issues, but also books now out which help you to understand the mathematics and the computer science behind this work. Practice. So this is the main part where I would like you to understand that you can map your own data. This is the cover which we proposed to ACM when they asked us about suggestions. And they didn't go for it, but I think it's still very telling and it's characteristic for these tools which you're going to see. You might be familiar with tools where somebody else figured out what you're supposed to eat or use. So tools like this are, for instance, Photoshop or Microsoft Word or web browsers you might be using. Somebody else figured out what's in that menu system, and then you're just using a subset of all the many possibilities which these tools offer to you. What I have here for you is a tool where you go basically to a China buffet-like environment, and you go to the first tray or plate, and you pick some of the most delicious-looking data readers. And these are readers which read in your data. So this could be Excel files or network formats, etc. These are the data readers which you need in order to get your data into that tool. Could also be a database connection if you have a database on campus or in your company which you want to connect to. Next, you go a little bit over, and there are all these deliciously prepared data cleaning things. I already mentioned that 80% of your time is going to be spent on that tray, on those algorithms, on that activity. So you pick some of those unification algorithms which give you latitude, longitude if you give them an address string, other algorithms which help you to extract networks, etc. Then you go to the next tray and you might like to get some network analysis, modeling, visualization tools. Or you're more into temporal analysis, so you get John Kleinberg's burst detection algorithm or any of the other cool, neat new algorithms that are out there. And then, of course, you might also like to communicate results to diverse stakeholders. So you grab a few of the tools, the visualization tools, which are in the kind of right-hand corner. And you might also be interested to save some of the visualizations or some of the data sets out. So again, there's a tray for data writers. And so you basically cherry pick your favorite algorithms, you put them in the so-called plugin directory, and when you start the tool, they all end up in your menu system. And by the way, welcome to this brave new world where every morning when you can come to your office, you will see new data sets, new algorithms, new workflows that other people have created for their own purposes, maybe not with you in mind. But you will have a chance every morning to select some of them. Just like in some cases you might go to Twitter or to Flickr or to YouTube to get some of those resources. So what we are doing here is to help scientists to design their own dream tools. And as you know, even Galileo Galilei, he grinded his own lenses because nobody else was doing it for them. And it was the same for me. Nobody else gave me these kind of tools. I had to build them myself with a lot of help actually through industry standards and lots of programmers involved. And I will tell a little bit more about this later. But it's really a matter of taking what exists, repurposing it, extending it, and inventing hardware and software that you need ultimately for your dream come true tool. So you might wonder, what are macroscopes? So you already heard a little bit about the plug and play, but what about this macroscope business? So many of you might be familiar or maybe even own a microscope and a telescope. And as you know, in former times, there have been researchers which used the same microscope or the same telescope for even their entire career or at least a major chunk of their career. And then maybe they got a new one, and that was way better than the old one, so they used this. But it was a very static instrument. What I'm proclaiming here exists, and you will have to just face it, is an environment where you have very flexible so-called macroscopes which help you to make sense of processes and data sets that are either too great, too slow, or complex for the human eye and mind to understand. And these macroscopes evolve on a daily basis. And if you proclaim something like this to arts and humanities scholars, they don't want this. They just want a tool which they can become very familiar with. They have their data, which they know very well, and they just bring those two together and work with this. But I don't think this is reality anymore. I think you have to get to the point that you embrace this new technology and you embrace new data and you become a data junkie and you become really interested to try out new toys, basically, new tools, and have fun with them. And so, again, these macroscopes, which I'm trying to get you interested here, are continuously changing bundles of software plugins. And you might sort some old plugins out because they don't do so well, or they're too slow, or they don't work with the data you really want to analyze. But you might also hire a programmer or two on an hourly basis because you need that one more data reader, or there is this new algorithm and somebody coded it up, but it's not fast enough, so you really need it faster. So it's a very flexible way that millions of people can actually do small bits and pieces, and then if they share those plugins, it becomes something very powerful. And ultimately, just like you share images and videos via Flickr and YouTube, you can now also share algorithms via this kind of infrastructure. And to be honest, assembling a new tool is really as fast as collecting your new music library. And I think many of you are very familiar in how to do that. And so to give you another kind of food metaphor here, and you actually have these round tables here, and in some places you actually have tables here where you have people from different areas of science or from government and industry and academia sitting around this table, and they all typically have their own few of this world. They have different, for instance, in network science, in the study of networks, you would have social scientists which really see the world in matrices. You have scientometricians like me, information scientists like me, which see it as a node list and an edge list. And then you have physicists which just are happy to have an edge list because they're very interested, for instance, to understand universal laws, and that's all they need there. They, for instance, would like to find out if this network has a power law characteristic, and this is the data they would read there typically. So similarly, here around this table, you have people which typically cannot share their algorithms and their data readers and writers, etc. And so it's sad. And by the way, there's some woman involved. So what we tried to do is to create an infrastructure where you can plug and play data sets and algorithms. And we went through a number of iterations of the core, which then lets you plug and play. And after 3 attempts, we finally settled on OSGI, which is the Open Service Gateway Initiative, a big industry standard, which allows to build modular software infrastructures, which you can typically find in cars, in coffee machines, in washing machines, etc. Yeah, different ways to just modularize software. And I would argue this industry standard has cost more than NSF, NIH together could afford for building modular software designs. So we are leveraging this, and then we added a very small piece of software which we call Cyber Infrastructure Shell, or SciShell. And that's a specification and prototype implementation that basically creates sockets into which you can plug and play data sets and algorithms. And what you then can do is you have developers, which might come from different areas of research, and they have algorithms. So typically grad students implement those algorithms in whatever language they speak, right? Fortran, C, Java. And then you have so-called wizards, which help you to get your data or your algorithm wrapped up into a jar file. And these are the jar files which you can save in that plugin directory, and then they show up in your menu system. And this is all then plugging into the SciShell itself. And then on the right-hand side, you have users, again, which are not computer scientists, and they create their different types of tools. And they start building workflows. So I already mentioned the workflow of all the data acquisition, pre-processing, analysis, layout, and then visualization, and then going back, realizing that you don't have the right data, doing it all again, etc. In many cases, the workflows are also used in teaching, so it's very important to have a wiki environment which you can use to really document in detail how this all works. And so as you see, computer scientists are really only needed to create that empty shell, just like you needed computer scientists to set up Flickr and YouTube. But when Flickr and YouTube had no content, it was totally useless for all of us. And similarly here, just the core itself is very small. It's very easy to maintain also, which makes it very possible to sustain such an effort in an academic environment. But the value comes through all these algorithm plugins. If you get interested to check out what we did there's a very detailed documentation on how to do a little Hello World Java application and integrate it as a plugin, how to integrate Java code itself, how to integrate non-Java code. So feel free to use this infrastructure to just organize your own code. You don't have to share with anybody if you don't want to. But some of you might actually want to share your own algorithms this way. And we have a good process in place that you can actually get citation counts for sharing. We are using the normal currency of science here. You can also go to scishell.org and see a number of the tools which now are SciShell powered, if you wish. And the big advantage of having a SciShell powered tool is that you can take plugins from one tool and you can plug it into another tool. One of those tools is the Network Workbench, which has been downloaded by more than 110,000 people, but we unfortunately don't know what people do with it because there's no registration. You just go there, you download it for your specific environment, and you start playing with it. And there are more than 170 different algorithms now in that tool, so you can play for a while. It has been used in computational proteomics, and in the interest of time, I'm just going to mention those, but all the links to the papers are here. Computational economics, the product space work, some of you might be familiar with. Computational social science, we mapped all of the English-speaking Wikipedia using the tool, so it scales very well, and compared to Gephi or Cytoscape or other tools you might be familiar with, it has a lot of data analysis algorithms for directed but also for weighted networks, which you might be interested in. Also computational epidemics and others. The second tool I wanted to mention, which is maybe more relevant for the data you have, is the Science of Science tool, which was funded out of NSF. And here you have different network visualizations. You have these horizontal time graphs. And you also have science maps, which you can use to overlay the expertise profiles of a single person. Like, for instance, you can read in my EndNote file with all of my publications, or an institution's profile, or an entire profile of a conference, and overlay those. You can do simple geomaps, and you can also do hierarchical network analysis using Blondel, and then map these hierarchical networks using this circular hierarchy. The tool comes with extensive documentation. So I worked at NIH for months, and there are 24 hours of video documentation if you're interested. But I thought what I should use my last 2 minutes for is to really take a data set which is relevant for education. And what I did was to go to the NSF Award Search, where you can download all the fundings that NSF has given out. And I typed in as NSF organization DRL for Division of Research on Learning in Formal and Informal Settings. Anybody is funded from this? Can I see some hands? So you might be on the map, watch out. So there are 769 currently active awards, 891 unique PIs funded by 73 different programs. And the sum of all the awarded amount to date is about $1 billion. And this $1 billion also comes into existence because you have projects which have been starting very early, like as early as January 1st, 2002. And they are going to expire soon. But then you also have projects which just started, and they're going to go on for another 5 or longer years. The data looks like this. You have a title, you have the NSF organization, which is all DRL by design, given that I constructed the query this way. You have the different programs that fund it. You have a start and an expiration date. You have the organization, which actually is involved, and you have the awarded amount. You have an abstract where you could do very interesting topical analysis, which I didn't do here. And you have all investigators, which are listed as PI or co-PI on the award. First of all, you can map all these many grants using so-called horizontal bar graphs. So here you have a bar which has text on the left-hand side. So you see here, for instance, the title of the project. Then you have a start date and an end date, which is the expiration date here. And you have an area size that in this particular case equals the dollar amount. And you can look at this all, and you can browse through it, and you might like to find out what are the big bars, lots of money in little time, for instance, or what are the ones which are still in existence and still going strong for a number of years. So you can, first of all, map all this, and you can also, if you want, color code, for instance, by gender of lead PI, if you have that information. Or color code all those which are career awards or equipment awards, etc. Then you can also extract collaboration networks from this. So for instance, all investigators just extract the co-occurrence network of that one column which had all the investigators in it. And then visualize it using, for instance, one of the built-in visualizations or Gephi or any of your favorite tools. So here you see it's rather unconnected. And if you zoom into this area here and then kind of turn on the labels for the nodes, you get to see some of the larger networks that exist in this particular data set. You can also do bimodal networks of PI institutions to co-PI networks. And again, you have here, actually, you have a giant component and some smaller networks. And this is the giant component, and I thought you might be interested to see who is in the middle of all of this. So again, these are the institutions of the lead PI, not the institutions of all the other co-PIs, just the lead PI institutions. And then those connected to all the PIs which are listed on the entire award. And you might like to not only see the labels for the institutions, but also for those people nodes which actually are interconnecting different institutions. And again, you can also visualize this in Cytoscape or Gephi. So you can integrate entire tools as plugins. We have a new tool which is funded out of NIH, and that actually also created an OR bridge. So if you're an OR fanatic, you can use this. There are a number of European projects now which add a lot of textual analysis algorithms. And ultimately, if you are interested to create your learning analytics tool, you might like to just take an empty shell and see what readers and what processing and what analysis and visualization is relevant for your life and decision making, and then just add them into an empty shell and brand it under your own name or under learning analytics and have fun with it. Thanks so much.
Katie, thank you so much. Hopefully you are as blown away by that as I am. And the fact that this isn't just sitting in labs, this stuff is available to download now. So I know we have information visualization people here, and there's a real invitation from Katie to engage with her for the rest of today. She's around just the rest of today. We have got time for maybe one or two quick questions if somebody would like to ask anything. Otherwise, I'm picking up big let's get coffee signals. Okay. Katie, are your slides, can we get a copy of those?
Sure, yeah.
So they will go up on the LAK site.
There are also handouts here. If you just want to see all the many algorithms you now have at your disposal and some of the workflows you can use to run some of your own data, just pick up some of the handouts.
I'm looking forward to the LAK 13 InfoVis panel where we might show the Learning Analytics portal. Katie, thank you so much.
Sure, thank you. So again, it's not a learning analytics tool, but I think it does a lot of these things that you might like to do. Have fun. Yeah, we do. We like toys and tools. There are more handouts on some other aspects.
First session after the plenary of the morning. So my name is Agatha, and we have this session of visual analytics now. And our first speakers are Anna and Alfred.
Thank you. Good morning. Ready to rock and roll here. So first, my name is Alfred Essa. I'm Director of Innovation and Analytics Strategy at Desire to Learn. And this is my colleague, Hanan Ayad. She's a Senior Research Scientist and Technical Product Manager for Analytics. We're going to talk about design. So this is really a session on design, and what we're trying to do is put together an application and harmonize three elements of design. One is sort of product design, second is engineering design, that's underneath the hood in the application, but we're not going to talk about that today. And the third one is research design. I will spend a little bit of time providing context in terms of product design. What's the application? So we're building an application called the Student Success System. So what's its function? And then I will assert some design principles. And there's a problem set that we're trying to solve. And that's connected to the research and visualization aspect of this presentation. We'll do a very, very quick lightning demo of the visualizations to give you a flavor of the application. And then Hanan will concentrate on the research problem set that we're trying to solve as part of the application design. and then our solution. The heroes in this story are two people, Sir Francis Bacon and Aristotle. So that's, as we go through this, think about that. Okay, so design principle number one, just going to assert that from a user experience point of view, our objective here is less data, not more data, but less data, more insights. And then underneath the hood, from a systems perspective and engineering, we need more data and less complexity. So from a design perspective on the user experience, we want less data, more insights. The goal of the application is, and the pioneer in this space is John Campbell in the Signals Project. We want to make predictions, identify at-risk students, but also a very, very important category is to identify exceptional students and then design interventions and communication for that. The workflow of the application, imagine the patient-physician relationship. So the workflow, typical workflow in that relationship is first you want to understand the problem, next interrogate the data, consult with others, prescribe a course of treatment, or design an intervention, and then track the success. So that's basically the overview of the app. Design principle number two is the goal here is not prediction. It's really optimization, and I want to just explain that very, very quickly. So this is a slide that kind of goes over analytics maturity levels, kind of a shorthand for different levels of analytics maturity. So at level one analytics, it's really data about the present, data about the past. It's reporting, and at best, this is what's happening now and what happened in the past. A lot of analytics is really at that level. But analytics level two is what will happen if we don't change our assumptions or if we change some assumptions. And that's when we start to get into things like predictive modeling, forecasting. But the holy grail of analytics is optimization. It's really what we want the desired future to be, what should happen. And just one way to think about optimization is whenever you're in a current state and you have a desired future, there are multiple pathways, and the goal is to find the optimal path. So the way we think about analytics is really it's an optimization problem, finding among the alternative pathways that exist, which one is the optimal path. Okay, so now let me state the problem set in the application. The signals model, which many of you are familiar with, makes a prediction. The context is a student in a course, and it makes a prediction red, yellow, green. The limitation of the signals-like type model, and I'm going to put that in quotes because it's not to isolate signals. Signals may have gone beyond this, so I'm just going to say signals-type model. The limitations are interpretability, interactivity, and portability, and let me explain that very, very quickly. So this is a very rough conceptualization of the signals-type model. We have a student and a course as input. There's a function or a model, and you get an output green, yellow, red. Now imagine if you're in the healthcare sort of example, you're a physician, and a patient walks in, and the system, the analytics says red, yellow, green. There's not much to go on. I mean, that's helpful, but if the end goal is to design an intervention, I need something more. So the first limitation of the signals type approach is interpretability. There's not enough information if the telos, the end goal, is taking action. There's not enough information for the intervention. Second is lack of interactivity. We need to be able to interrogate the data, make sense of the data, because our ultimate goal, if you're going to design a meaningful intervention, it's about the particular case, the particular individual, and all the surrounding factors. The third limitation of the signals type model is lack of portability. Same model applied for every course at every institution doesn't take into account the variability of learning design, instructor, course context, large courses, courses in sciences, humanities, etc. So this is the basic problem set that we're going after from a research perspective, and Hanan will elaborate more on that. And also part of the answer is visualization. So let me do a quick lightning demo of the app, and we're not going to go through the entire app, but show you some of the key ideas in the app and the visualizations. So this is a student success system. Imagine you're an advisor or an instructor. You have a number of students, red, yellow, green, risk predictor, name, picture of a student. So first I'm just going to click on, I just want to see which students are at risk. One of them is Eric Cooper. I'll click on him. And this is Eric Cooper's profile chart. This is intended to provide an overview. There's some demographic data, et cetera. We see that Eric Cooper is a full-time music student, et cetera. The first visualization is a win-loss chart on the left. So we first isolated the fact that Eric Cooper is in trouble. He's at risk. And with the win-loss chart, what we are able to do is get a quick reading on what risk factors are contributing to the prediction. So we see here that his attendance rate is negative. He's not essentially logging in. His completion rate is also negative. His participation rate's kind of average, et cetera. So this is intended to give a quick glance at to what risk factors or risk domains are contributing to the prediction. Another visualization that we have is a risk quadrant. Each point, so now we're looking at the math class that Eric is a participant in. The risk quadrant is 4 quadrants. Each point represents a student in the class. Top right-hand quadrant are the students who are on track, not at risk. Bottom right-hand quadrant, we see 3 students who are at academic performance risk. That means that our prediction is that they will end up getting a D or an F. Eric Cooper, along with 2 other students, are in withdrawal dropout risk category, and then we have 2 students who are in the top left-hand quadrant, and they're underengaged. That means that from an academic performance point of view, they'll be okay, but they're not engaged fully. At this point, a very, very critical part of the design, we need to be able to merge quantitative data and qualitative data. So I just clicked on notes, and this pulls up sort of a case history, CRM type capability. What's the case history of Eric Cooper? And I'm not going to read all the stuff in there, but this kind of gives a running account of the types of touch points and interactions that Eric Cooper has had. And we see, for example, that he's seen his advisor a couple of times, had some interactions. So this allows me to develop a better qualitative picture of what's happening with Eric Cooper. Now, if at this point I'm ready to make a referral or design an intervention, what this screen would pull up is what are all the service options that are available at your institution, and which ones are relevant for Eric Cooper. I'm going to show just one other use case. Another use case is we have Kate Johnson. And what we see with Kate Johnson is she's taking 4 classes this term, biology, chemistry, computer science, history. We have predictions associated with each one. So in 3 of our courses, our predictions are green, she's going to be very successful. History, troubled waters, turbulence. So we have a red prediction. I'm going to click on Kate Johnson. We, again, look at her win-loss chart. And when we look at our win-loss chart, her attendance is okay. She's coming to class. She's completing her work. Her participation rate is about average, a little bit below average. What's troublesome is social learning. And so what does that mean? So we're going to click on sociogram. And now this is a prototype, but this is sort of the network graph of her interactions. And what this is picking up is Kate Johnson is an isolated learner. And so imagine a model or a context in a class where collaboration, group work is essential for success, and there are early signs that she's not interacting with her peers and others who are important in the context of that class. So here's some of the visualizations, and Hanan will kind of dig deeper into the model underlying this. So I'm going to turn it over to Hanan to describe the underlying modeling.
So I would like to talk about the ensemble modeling, which is the technique we're applying here to tie up and inform the product design from the scientific perspective. And I'd like to talk about three different aspects with regard to ensemble modeling. Again, the technique that we're applying. So the first is what it means from a conceptual perspective, what is ensemble modeling. The second point I'd like to talk about is from a statistics and machine learning perspective, why we're using that. And the third is the application domain. From an education perspective, how do we apply this paradigm, this new technique in the education, specifically for predicting student success. So in terms of what it means from a conceptual perspective, ensemble modeling really means collective intelligence. Is for us to be able to improve decision making, to optimize decision making, and Al talked earlier about optimization. We can't rely on a single expertise. We need to bring together multiple, we need to form a committee and bring multiple experts together to optimize our decision making. You can think, for example, a patient who has a problem might want to seek a second opinion, for example. Even a medical doctor might want to investigate different sources of information and bring different tests to optimize his own decision making. So the idea behind ensemble modeling is the collective intelligence and bringing together multiple expert systems to make better decisions. So if we think again of, in the context of the signals model, you have the student and the context in which the student is learning. And then you want to form an intelligent system that allows you to determine their success level, whether the student is successful, is potentially at risk, or at risk. And the key idea here is that we want to preserve interpretability, interactivity, and the accuracy of the prediction. The ensemble, from a statistics and machine learning perspective, the idea of ensemble modeling, the key motivation behind it is improving the accuracy and the generalization of predictive models. So there is actually a very large and strong body of research behind the idea of ensemble modeling. And as I mentioned, the key motivation here is improving the generalization and the predictive accuracy of these models. So instead of relying on only one model or a single hypothesis or an expert predictive model that is trained to make better decision, why don't we build multiple hypotheses? And through a process of consensus, we can combine these decisions from multiple different perspectives and optimize our decision-making process. So that's the fundamental idea here. And there are, as I mentioned, there is a strong body of research from mathematical proofs to large-scale experimental studies and benchmarks that shows how ensemble techniques can improve the decision-making process. Also, the ensemble modeling paradigm opens up a lot of design choices. If you can think about it, well, what are the different hypotheses we want to test? What are the different data sets we might want to look at? What are the different features of these data sets that each model might want to look at? And also, what are the consensus functions that can combine all these decision making? So it opens up a lot of design possibilities. And what we want to do is to leverage these design possibilities in the education paradigm, in the application in education, or in that particular problem of predicting student success. So taking that back to the design of the student success system, we want to look at the overall prediction and decompose that into multiple domains that we can build predictive models that specialize in these domains. And you can think of the social learning, for example. We can look at the social network and perform some social network analysis and even some text mining on the conversations that are going on, that's going on between students to build specialized models in the social learning space that can provide us with some predictions that are pertinent to these to this type of features and domain data sets. You can look at other things, participation or content comprehension, for example. We don't want to look at what are the number of topics that students have read. There is a difference between, for example, the introductory material versus the more advanced material and how much time they spent. Maybe they spend too much time on advanced material but not on the fundamentals. So all these domains, and then around that, there are so many other dimensions, such as the time, the different courses, the different programs, and the different competencies that the student is acquiring over time. So the idea here is to build these semantically meaningful units that we can combine their decisions in meaningful ways and tie them up to interpretive displays of the data and have better accuracy in our models. Thank you.
Just to wrap up, and this is where Sir Francis Bacon and Aristotle come in. The signals type approach, the basic limitation is that the predictions are black boxes. And what we're trying to do here is to open up the black box through this semantic units so that we can probe. So Sir Francis Bacon is the originator of the scientific method. And so we want to be able to peek inside the black box and interrogate it. And where Aristotle comes into the picture is the idea of judgment. Machine intelligence predictions are not enough. We have to couple that with qualitative data and the ability to make judgments, whether it's an advisor, the student himself or herself, as well, and an advisor. So thank you.
Thank you. So as usual, the microphone is here for questions.
Those were really nice visualizations. I liked being able to kind of drill down. One of the things that we're constantly having problems with is uncertainty. We tell our faculty, okay, use our LMS, and they say, okay, but they don't use it for class discussions because they want to use something else, or they use some new tool that we've never heard of. How does that factor into these? How can we build models that quantify this uncertainty, or at least recognize it and then ignore it? So for example, we might have a small class where discussion isn't important at all, yet we've got all these giant red bars for people that say, oh my God, you haven't been talking enough. Could you just touch on how that might work?
Yes, actually going back to the design of the predictive models, decomposing it into multiple domains that are visible to the instructor, the social learning, for example, as opposed to the participation or the attendance and so on, opens the possibility of tuning these models as well. So providing them with visibility into how much they weigh in the context in which the course is taking place, and giving them the ability to have control over these weights as well. For example, if most of the discussions are actually taking place in class, face-to-face, then they might not really be interested in what's going on in the discussion forum, and they can choose to turn off this domain completely, which is contributing to the prediction. But again, it's combining multiple models. You can remove and add models as you wish. And this is the design framework that we are trying to build, is to make it modular so that you can add and remove things depending on the context in which it's used.
Thank you.
Yes, I have a similar question. To what extent are there plans to build analytics capabilities with tools that are built with the LTI protocol? So, bringing in outside tools that have this LTI data infrastructure, making it possible to add that to your models. So, like, for example, Panopto or Piazza, some of these newer tools that are built to interface with learning management systems from the outside.
Yeah, so we didn't talk about the engineering of this particular product, the student success system. So a client might say, hey, we're going to build our own predictive model, and in fact, it's proprietary, and we don't even want Desire to Learn to have access to it. So it's being architected in such a way that the predictive models or whatever is generating the prediction could be exposed, and we would just pick that up as a web service. So the actual engineering of the application is intended to be flexible.
We have no time for more questions, so there will be some more discussions at lunch.
Thank you.
Thank you again.
So good morning. First of all, I would like to mention that the slides are online. I am PhD student. My name is Jesus Santos. I am working in the Human-Computer Interaction Group at KU Leuven. It's a university from Belgium. And now I want to explain a bit about our paper, that it was goal-oriented visualizations of activity tracking, a case study with engineering students. So what was our main motivation when we started this work? We wanted to use information visualization as a means for providing awareness to the students that they could self-reflect to understand what is going on and give a bit of sense-making on this information. But even more important, because we have to accept that there are a lot of work done in this area, and we are even more interested to how engage the students to this process of reflection and getting conclusions and modify somehow the behavior of the user. Another point is that our courses are not done, or yes, they are not inside of one LMS. So also another important part of our research was how to track the information or the activities that go outside of the LMS. As a related work, we can say that we want to positionate this work inside of a bit of the dashboards that we can find in the learning management systems, not only because, it's even more important because we don't do sense-making in the way that we give an idea on if they will succeed or something like that. It was more important from the perspective of the design. We want that if the users get used to use some dashboards, we want to use more or less the same criteria for the design. Also, we positionate a bit our work in the way that the students should reflect on during the process of the activity. So they should see what is their activity. For instance, in the first case, Narcissus, it's about project management. Also, it's a really pretty close case study from us. Also, that I think after the next session, the other session, our colleagues from the University Carlos III of Madrid will present the other tool that is GLASS. Also, it's visualizing network activity of the users inside or outside of the LMS, but inside of a virtual machine. And finally, another fellows from Italy that they visualize basically activity more than success or learning. But what is our previous work? We did also the student activity meter that was also visualizing time spent per activity. And the other tool that was really important for us because it was a really first stage that we did. And we presented in our workshop, and they told us that it was more or less nice, but it's really important when we see a visualization that we know the context that we are visualizing, because otherwise it's really difficult to understand what is going on. Also, as an inspiration, I just forgot to mention that as a conclusion of this kind of context, we wanted to use this concept of goals. Goals may be not so oriented like learning goals. It's more maybe oriented in this quantified self approach that we have. It's that the user can say, okay, I want to be more active in this kind of activity because of that. I want to achieve these goals, but more oriented to the activity. We are more focused on the process than not in the final goal, learning goal. For that, we use the design-based research methodology. Maybe this methodology is a bit different because we don't start with big research questions, but it's a really good opportunity to get early feedback, earlier requirements from the students, and it's based on that. We have a problem, we try to design an application, we implement it, we deploy it with the students, we try to observe, evaluate what is going on. Also, the good part is that we are also teachers or teacher assistants from these courses, so we also see how the students are performing. And finally, we try to analyze all this data, we try to find somehow correlations, and finally we get some kind of requirements for the next iteration of the tool. So in that case, we did 4 iterations. In fact, we did 5, but in the paper are included only 4. And basically, we start with the typical paper prototype. We design something, we evaluate it in that case, because we cannot go to the students and ask them, what do you need, what are your requirements, because they even don't know what is going on in the course, what will be the objectives. It's difficult to get this information. So we go a step ahead, that is the digital prototype. Also, we evaluated with teachers and professors. We did a first release that we evaluated with students, and finally also a second release that also is with the students and their data. That is the most important thing. In the first and second iteration, as we didn't know also where we want to use it, we use a generic approach. We use the contextualized attention metadata specification, and we try to design a dashboard for that. We evaluate in these iterations the usability based on interviews and think aloud protocol between 15 and 30 minutes. In the first was 7 participants. In the second, 5 participants. And in the previous slide was already mentioned, was basically focused on teachers and teacher assistants. What were the conclusions? That, for instance, as we can see in the previous slide, just the first widget was a table. A table is a really nice visualization for getting an overview of what is going on in all the class, but all the course, but yes, when the size is increasing of the students, or for instance, in that case of the goals, the table that also, it's something that happens in the Khan Academy, you get somehow lost in this kind of visualization. Also, we have to take care, because we were using the approach of visualization, widgets, that we shouldn't use or we shouldn't visualize redundant information in different visualizations, because the user, what is expecting is that if I have 2 visualizations are different information. So somehow it's important to take this into consideration. Also, the personalization. Not everybody has the same background with personalization. We are dealing with students, and most of them, they are not get used to reflect on visualization. So they spend sometimes quite time for trying to understand this kind of information. So personalization is important. Context centralization versus diversification. It means that as we were using widget technology, that also was something that we decide when was personalization, because in a widget container you can modify your widget that you want to add in your dashboard and so on. So every widget should contain what is the context of himself. Yes, and the final point is the motion chart, that it seems that in the literature you can find that the motion chart, it's a really nice visualization for visualizing three-dimensional data information, but it's some of them, I mean, that also I was commenting before, for personalization is one of the visualizations that can have problems for students to understand it because they are not really got used to this kind of visualization. So once that we did these 2 iterations, we decided to go for a real scenario, a real course for doing this kind of process. Again, we wanted that, I mean, the setup of the course was a programming course that they had to develop and program a code, a new program. We defined a really simple approach now because it was a first stage of our research, that it was goals. We had 2 goals. It was first report and second report, that it was the final report. And the idea, basically, they had to work in groups, so also they should they should learn how they spend during the lab sessions, their time during the lab session, trying to compare with their peers or something like that. So as engineering students, they have to learn not only to program code, and I mean, they don't only have to learn Java or so on. They have also to learn how to manage their time, what are their problems, and so on. Even more important also to choose maybe the peers of their groups, because when they go to the professional world, they have to have success. Why and what do we track? As I said, individual and group spend time. We track all the activity that happens in the desktop of the computer. We have to say also that we track all the activity more or less in an anonymous way, because we create special accounts for this course and we provide it to the students, like user1.group1@gmail.com or something like that. And then we give it to the students and create accounts in Rescue Time. Rescue Time, it's an application for tracking time in desktops. And also we track with Eclipse. Eclipse is an development environment, so how much time they spend in the different files of the project, what kind of activity that they were doing, like development, writing, and so on. The type of activity was provided also for Rescue Time by Rescue Time, that they have their own taxonomy for classifying all the applications. So they infer this information from what kind of application you were using. And the application itself, how much time do you spend in the application, and websites, and also the time spent on the different files of your project. So how do we visualize this data? Also, I have to mention that yes, this project, I mean this research, is involved in one European project, that all the code is open source, and you have it in SourceForge. And also, yes, a bit below you have the main screen, that are the 8 widgets that we did. But one per one, it's, for instance, goals on a table. We have here, as I said, really simple approach, that 2 goals, first report and second report. We have the students, And then this is the overview that, I mean, this is one of the widgets that when the student accesses to our dashboard, he can see. But he can see his activity and the activity of the others. So all these visualizations are interactive, so you can click on them, and then all the other widgets are modified based on this information. Here, now are everything green because everything was passed the course. So, but the idea is that we were using 3 colors: red if the goal has not started, blue color is that the goal is going on, and the green is something that already passed. So basically, in that case, goal means first report, and you have a starting time and a final time. The motion chart that also we talk about it. Basically, it was to compare their activity with the average activity of the group during the time. Also, you could click on the final report and first report, and you could filter this data in the following widgets. So here is, in that case, the evolution of your activity in the different kind of activities that you have done along the time. And then the next is the same information, more or less, but compare it with your group. So in that case, the information that shows is that the time that you have spent in the different activities compared with the total time that your group has spent. So in that way, you can see more or less what is your contribution to your group. In that case, also is concretely the activities that you have done. I mean, the applications that you have used. Here you have, for instance, also the comparison again, but per applications. Finally, is the time spent on your Eclipse documents and websites, also compared with your peers. Also, for instance, in that case, in this case, we can see that even one was working with Facebook during the class. The first evaluation with real data was just at the beginning of the course. Was real data, but was a bit fake, because what we did is tracking our own activity inside of the group, and then visualize it, did a demo with the students. We wanted to evaluate what is the perceived usefulness, what is the perceived usability of our application, and also, even more important, what were the privacy concerns, because we were tracking in their computer all the information, so maybe they were a bit scared about that. So we wanted to evaluate it. And what were the conclusions? For instance, in the case of the widgets, we can see that the average is more or less the same. They don't have any kind of preference at that moment of what they consider that it's better, the widget, or one or another. Also, it's normal because they still can't reflect on their own activity. So we did this kind of use questionnaire for the students, and we can conclude that the perceived usefulness was good. They consider it that they could, I mean, that it can help them during the course. And regarding the privacy concerns, they say that, okay, they are okay with the lab tracking, they don't have any problem, but we try to ask them, that is the final question, if they would agree to be tracked, for instance, in the case of being at home. And for sure they say no. In the second evaluation was after 4 lab sessions. We did it with a small group, compare it with the other one. It was with 10 students. We let them play with the application during 15 minutes, and afterwards they should they fill it in a SUS questionnaire and several questions regarding perceived usefulness. And again, if they agree with tracking a perceived, if they agree or they feel uncomfortable with privacy concerns. And everything was, again, with a questionnaire. So the SUS result was 72, that they say that it was quite, I mean, if you see the scale of this kind of questionnaire, 72 is that the usability is quite good. Usefulness, they were still a bit saying, okay, I am not totally convinced about the usefulness, but they could understand everything in the visualizations, and even they could understand certain patterns of how they were managing the use of the applications. Regarding the evaluation of the widgets, we see that there are mainly two widgets that they are more considered useful. And basically are those that you can compare your activity with your peers. So it means that somehow they are more interested to reflect on, I don't know if the reflection should be the correct word, but trying to know if the others are working or not. Final conclusions that this iteration was not included in the paper, but was with 14 students. We did again the SUS questionnaire. The usability of this application decreased a bit from 72 to 66. It was a bit disappointing, but still is considered useful. It was at the end of the course, so now they have all the information that they have generated. Also, we have the graph that they, compares basically what was the difference between the answers from the previous iteration to this one. And our personal conclusion is that basically the usability also decreased a bit because there was more information included in the dashboard. So for them, it was a bit more difficult to understand all the problems. Also, we asked them because, okay, maybe it's a problem that they feel a bit scared with that this is more useful for teachers than for students, and maybe it's the thing that maybe they have problems on. Our results was that 6 students say that was more useful for teachers than for them, but the positive side was that students says that for 5 students they say that was more useful for students, and 3 say for both. So we have more than 50% saying that can be useful for students. So it's not something bad. And I think that is positive. And the level of satisfaction was 4.4, that, okay, was not great, but yes, I think that they can have a really good use of this kind of application. But we have the problem. Although they consider it useful, understandable, usable, the real stage is that we didn't force them to use the application, so they could go and access to that, and the results is what they didn't use a lot, this kind of tool. Why? One student said that we had other priorities, and it's partially true. I mean, they don't realize that reflection can provide them a really useful feedback, and maybe it's part of our research that we have to engage them to this process of reflection. That they have to get used to this kind of reflection. So this is the final question that we have, and that we are working on. And for instance, in that case, we are now in other 2 studies that are trying to simplify all the visualizations, because we want somehow that they go to the website and they get engaged with the visualization or something like that. So we started with a table, and finally we want to do a really small widget, like in the previous presentation they did, with a really simple semaphore red light traffic, that you can see, okay, I am going well, I am not going well, compared with the average, and so on. So, yes, it is all. So if you want to follow us to have more information, feel free to follow us on the net. Thank you. Yeah, basically, I mean, even as a funny part of the experiment, I mean, at the beginning, for instance, in the first iteration, we had 36 students. In principle, we had to do it with all the students, but we cannot force it to use our application because it's against the law. So the funny part is that at the end, we installed the software in the computers of the lab. So they did, I think at least half of them, they did the trick to bring the laptops saying that they wanted to work at home with all the software. So they skip the part of tracking. So at the end, we have only half of the students working on that. And basically, what they told us is that they don't really feel comfortable with that other students or even us, we can look at them what they are doing, because for them they are enough autonomous for doing the work. But yes, after our observations, we see that this is not true. I mean, basically the person who was more rejecting this kind of tracking were the people who was not so really active during the course. So it's difficult to manage with that, but still trying to find the final solution for that.
So to be able to use the software on the lab computers and for those students who did elect to be tracked, was there some sort of review process that you had to go through in your institution, like a review board, to be able to collect that data and analyze this? Or was it just part of your normal course operation?
It's not part of the normal operation, but we didn't go through a review process. I mean, we let them know that they could stop and start the tracking. They feel free to do it. For sure, we are giving them some pressure because we are saying that it's a part of our research, but they could do it if they want, but nothing else.
And just a last follow-up. So the student who was using Facebook, do you imagine any interventions coming from this or making this tracking part of the course grade, something like that, so that if a student is off task that you could intervene and counsel them, or is it just part of helping them become self-reflective and self-monitoring?
Yeah, I mean, we are not so interested in intervening in the process. I mean, we assume as normal that they can use Facebook. I mean, the problem would be if half of the class they are in Facebook, but maybe in that case, yes, we can do something, but in principle, they had this dashboard for them. We didn't do a dashboard for us, so because we were trying that they get free of this feeling that we are observing them. We don't want to observe them. I mean, we want to provide them tools for reflecting on their own activity and nothing else. But we didn't really get this goal.
Yeah. Thanks for the presentation. That was really good. One of the problems I'm struggling with, so I don't know if there's an answer, but the goal is reflection or some sort of learning impact. And at the early iterations, you're showing them data that's not their own data, which would help reflection. Mm-hmm. Is there any way to help close that between the two, between the fake data and the goal early on? Did you find any way to methodologically help them, put them into a scenario or?
I mean, in that case, I think that was pretty close the scenario that we were using with the fake data, because in that case, fake data, we were using fake data of our daily work. So we also work with computers. We also work with programming. So we were trying to really simulate or emulate the real scenario that they were working on. So, but even though I think usefulness, I think at the end we saw that yes, usefulness was quite good, but they have still problems to really figure it out because they cannot link with their own activity, because if they see what was their activity and the visualization, they can link it somehow. But with our information, no, they couldn't. So it's a bit, yes, struggling on something. It's really difficult to fix it. Yeah.
Thank you.
Yeah, thank you.
Yes, so let me just send some greetings home to my family. Where's my presentation? Hallo, Frieda, Pauline. Papa ist bald wieder da. I told them they have to go to bed after my presentation. So, I will be talking about Apostel, and the Apostel project has already ended 4 years ago, and we are still working on this without getting any money. So this is really real research spirit, I would say. So here are my colleagues from Graz, and I'm Tobias, and I also used to work in Graz, and now I'm in Tallinn, at Tallinn University, where we're continuing also some of this stuff. So Apostel is a adaptive system that is used at the workplace, and we're following their adaptive learning systems paradigm. So it means the learning system tracks what people are doing with it and makes some inferences about some of the characteristics of the user, and then gives some recommendations what they should be doing next. And one of the problems with adaptive systems is that, at least in traditional systems, this user modeling, how it was called, was very often secretive. So the system made some inferences, but the user wasn't really aware of that. And this is the problem that we are tackling with this with the system that we are presenting today. So opening up the user model and visualizing the system to the user to, of course, also make it possible for the user to reflect about what the system knows about him. So I'm going to be very quick today. Just 3 things I want to talk about. 3 of the main issues that we had with this system. So we are talking here about an open-ended learning environment that is used in the workplace. So people should be using this as part of their normal work. We are talking about fairly large and complex learning domains. So they're not so easily modeled as maybe some subjects in the educational field. And we wanted to present results of implicit diagnosis. So not present people any tests or so they have to fill out, which we found not really to be appropriate in a workplace setting. So and therefore my experience was created, and it is non-invasive, and it should reflect what people are naturally doing at their workplace with Apostel. Because it's a large and complex learning domain, of course it has to reduce complexity, has to fit a lot on the screen. We saw some nice visualizations today, which also went into the same direction. And because it's all implicit, it has to be somehow intuitive, because people are not actually noticing what's happening there, and it also has to be correctable. So we wanted people also to be able to correct what the system knows about them. So there has been some work in non-invasive knowledge assessment, and it has been used in educational systems, and I've listed some of them here in adaptive systems. But in workplace systems, we found this has not been the case to the same extent. So most of the work has been performed in the educational domain. And of course, open learner models have been around for now quite some years, and they have been found to enhance reflection about the learning process, but also these results mainly pertain to educational settings. And here are some of the assumptions that we had. These were also empirically found within the project. So at the workplace, we assume that learning is mainly self-directed and it's driven from the tasks that people are working with. That learning makes use of existing resources. And these resources are organizational resources, so they are not necessarily designed for learning purposes. We assume that learning at the workplace is a social process in which people also switch roles all the time. So at one point they might be learners, at some point they might be working in a domain, at some point they might be supporting others. So frequent changes. And we also assume that there's a lot of research showing this, that experts actually act differently than novices. So it's not just a matter of doing the same thing better or more of the same, but they are just acting differently. And therefore we thought more appropriate model here would be to look qualitatively also at what people are doing. So not only have a score from 1 to 10 to measure their expertise, basically. And here's how Apostel looked like. So was a result of a 4-year research project. And we have people working at the workplace. So a system is designed for knowledge-intensive work, like engineering, consulting type of work. And you see that, it is just running along the normal work tasks that people are doing, and it recommends, for example, some resources, some people, some experts that might be helpful for the task that a person is doing currently. There are some communication mechanisms, so you can contact these persons, ask questions, get help, and you can also design kind of your learning goals in a certain domain, and then get reminded of new materials that are made available. So that's just to give you the context of where we're doing this. The Apostel user model is an overlay of the domain model, as is also very often the case in adaptive learning systems. So Apostel is a generic application, and it gets basically instantiated by domain models. So here you see 4 workplace domain models that we have modeled and that we have used Apostel with. So innovation management, regulations on chemicals, simulation in electromagnetism, and here are some of the partners that we work with. And here is what EADS is doing. Yeah, so they are dealing with the situation that what happens when your plane gets hit by lightning. Does it still fly or does it drop to the earth? So it seems to be quite an important thing to worry about. Yeah, so that was the. So they're writing basically simulations on electromagnetism. So what happens in these events to the airplane? And here you see, the kind of entities that we modeled. It's not the whole domain model, but that's what is important for this talk today. So we have modeled some tasks in these domain. We have modeled some topics, and a very simplified view on part of this domain model is that a certain task requires learning of certain topics. So that is the basic structure. So that also allows us to infer, for example, that when people are frequently working on a certain task, that they might have knowledge about certain topics. I said we wanted to make this assessment implicit, so we are just basically observing what we call knowledge indicating events. So all the events that happen in Apostel that we think have give us some indication on the kind of knowledge that somebody has about a certain topic. And we have separated this assessment into, let's say, 3 levels. So we want to find out whether somebody is rather a learner, rather looking for information on a certain topic, whether he's or she is a worker. So that would be someone doing tasks but not asking other people very frequently, or whether one person is a supporter, so supporting others in their learning. And here we have some of the knowledge, some of the events that we are tracking, and where we classified basically this event. And then the algorithm is very simple at the moment. It just is kind of a majority voting. So for one topic, if people do a lot of learner events and only very few worker and supporter events, then we assume they are learners, and the other way around. And then you have some neutral events that we haven't really classified here. So, and here it's how the user model looks like. So this has been the result of basically 2 strands of research. So one is the whole development of this application was heavily user-driven. So users were involved. So this is through several iterations. So this is not only some idea we had and then implemented it, but it actually went through many iterations, the whole system, but also this user model part. And the second one, we employed some principles from information visualization, which I'm going to show later on. But let me just give you an overview here, what you see. So you have these 3 areas or knowledge levels that we assumed. So whether you're a learner, whether you're a worker, or whether you're a supporter in different topics. And the topics that you see here are then the topics from the domain ontology. And as I said before, depending on what you are doing with the system, so whether you're looking for information or creating some learning paths, that will decide in which part of the learner model this topic will be put. The colors show, the intensity of the colors shows how frequent these interactions have been. So some principles from information visualization. So it's very well known that people are quickest to find certain things in these tree views. So therefore we have also provided this tree view visualization where you can just drill down through the hierarchy of the domain ontology. And coordinated with this, we have a tree map view. It means that's a space-filling visualization. So it means it puts all the information you have on one screen. So it gives a very good overview of what has been your main areas of work, for example, and where have you been doing things. So that's one of the Ben Schneiderman's information visualizations principles. So you should give an overview first. So that's why we decided for this tree map. But then you should also give possibilities for people to drill in. So you can have a filter here. So you start typing just a full text search, and then it filters out the things that you started typing. And you can drill in by clicking. So if you click here, for example, then it zooms to show more details. And the detailed view then looks like this. So you have here the element of creativity techniques. And there you can see what kind of events the system tracked. So, for example, this user selected three times selected learning goals about creativity techniques, performed a topic, so it means selected the topic and looked at the documents, and 12 times performed a task. So, therefore, this user was found to be in the I think the colors are mixed up here in this, so it should be a should be a learning should be on the learning side. Okay, and then you could also actually go back to the events that you actually performed. So if you, for example, know that you were looking for something on creativity techniques, then you could actually revisit the search that you did maybe a few days ago or a few months ago. So to conclude, the knowledge indicating events, as we have defined them, track the naturally occurring interactions in this learning system. The tree map visualization is intuitive, and it was also accepted by the users. We haven't made usability studies, formal usability studies, but it was more informal evaluation of people actually using this in the workplace. And they found this especially helpful for comprehending the domain model, so what the domain model actually entails, and also to enhance their reflection, so to see what they have been doing over the past few months. And we're currently analyzing more in a data-driven manner actual knowledge indicating events that people have produced at the workplace over a few months periods, but this will then be a paper for the next conference. Okay, and then I can report finally that we got a new project just accepted at the EU. So we are now moving to more traditional industries with this approach, so not to engineers and consultants, but actually to the construction site where people are running around with their mobile phones, and we want to put much more emphasis on learning analytics, social semantic learning analytics, so how these models that in Apostel we had basically fixed now actually emerge in their work. And yeah, it's quite a large project, and it was also very well received. So if you are a student, or if you know a student that would like to be involved in this type of work, I'd be happy to talk to you or in the break. All right. Thank you very much.
Thank you for the presentation. One question I have is regarding that 3 layers you talked about, worker, supporting, and learner. What is the rationale behind defining these layers? Is it based on literature or requirements of the workplace, like the specific domain? And then what is the reason behind the mapping of those knowledge indicative events and each specific layer? I mean, why do you say that editing and annotation is an indicative of a supporter role, but like creating the annotation itself is done by a learner? Thank you.
Yeah. So first question, where do these 3 levels come from? Well, as I said, we assume that experts just do different things than novices, so that should also be reflected in the sense that they're doing different kinds of things with the system. So that was the basic assumption behind it, and there's quite a lot of research showing this. The 3 particular levels came from many different, for example, from research into knowledge work that look at how knowledge workers actually deal with information at the workplace. So there's like conceptualizations there that suggests that you can differentiate it into these 3 basic activities. You could, of course, try to come up with much more fine-grained analyses, but because this was really designed for workplace practice, we needed kind of the metaphors and that are very intuitive, so that people can take one view and basically understand. So that was also one of the reasons that we simplified this approach very much. And then it was very pragmatic approach that we took. You could, of course, employ, and I'm sure many people would be interested to do that, some machine learning or something like that to classify now what other people doing and then classify them into these 3 levels and so on. But yeah, that is future work, and we wanted first to see how far we can get with this very simplistic approach.
Use an exciting microphone. One of the interesting things, I like the solution to the problem with scrutable user models because they are difficult for people to understand. But it makes it easier to game the system. Did you find examples of people deliberately modifying their user models?
No, because the user model is just for themselves, so nobody else can see it, and there's not really any use in doing that. I forgot to say that you can actually, you don't even have to game, because you can just click on one of those elements here and just change the level. So if you feel that the system has misclassified you and that you are rather a supporter, but you're not, the system hasn't tracked that, you can just change it. And actually the ones that have the star here, that's where people actually did this. And the only effect this has is that you're getting different recommendations, which I haven't talked about now, from the system, and you're getting different behaviors of the system. So there's not really any use in gaming.
Okay, good morning. My name is Derek Leoni from University Carlos III of Madrid. I am a PhD student in the telematic engineering group called Gradient. And basically, I'm going to demonstrate shortly about our tool called GLASS, which is actually an acronym for Gradient's Learning Analytics System. And these here are my colleagues who are also working on the project. I'm basically going to start first with the motivation or the description of the problem that we faced and that is pushing us to actually work on this tool. So there we were with a lot of data, actually tracking students, and we got a lot of the events or the actions that the students were doing in a learning activity. And we are in that explorative stage where we want to see what kind of visualizations we can come up with in order to obtain some hidden information that is in that data set. And in order to obtain that, we are facing many problems that it was very interesting also to see in the keynote or in other presentations of this session, that all of us face those initial issues, like, for example, having to process the data or having to filter the data in order to get them to a further step of visualizing that information. And so besides that, we also were seeing that although you could have different data sets, at the end, depending on how you structure your data, it will be possible to reuse visualizations that probably were meant to a specific context, but that placed or used with data of a totally different context. You could also get some sort of knowledge or information from that analysis. So the goal of GLASS is actually to serve as that platform in order to give you a basic infrastructure to start generating visualizations without having to worry on much of that initial issues that are faced at the beginning. Another interesting detail is, for example, that there are not two data sets alike. So there are always, even if you are in the same class, in the same group, and you measure something from one lesson to the next one, there are going to be very different details that come up later on. And it's important to have that kind of adaptation to the data as well, and be able to adapt the tool to the data that you are recording or collecting. And that's the main reason why we are doing GLASS. So I'm going to demonstrate GLASS and two visualizations that we have been working on. First, let me explain a bit about the context of the data that I'm going to demonstrate on. This is based on a computer science course, mainly a programming course. So students work a lot with programming tools, a compiler and IDE for developing their programs. And they also work with an LMS, as many institutions. So they have to, well, they don't have to, they are not pushed to use the forum. That depends a lot on the professor. But they are able to use the web forums in order to communicate and have questions and answers. And well, they also use the web browser in order to access to the course website, the resources, and any other external resource that they find on the web. So we are collecting mainly these types of data. And on the other side, the students work in groups. They belong to different sections. They also have different degrees or majors, depending. That depends a lot of every student. So they have their own characteristics that we could also use in the visualizations in order to try to detect those patterns that could be meaningful for even having an early warning system to try to avoid high dropout rates, or also to help them to actually learn better than what we had before with a less level of data collection. So I'm going to play the Brave card here and do a live demo. This is actually based on real data, but it's being anonymized, and you'll see that we cannot see who the actual students are. So I'm going to start with the first visualization that we developed. And the main idea was based a lot on Google Analytics, like trying just to see if we could find some pattern in the data that the students were generating. So on the left-hand side of the screen, you can see just the number of actions or events that the students were generating during the whole term, the 4 months that this class lasted. As you can see, the students are like working with some peaks, some kind of pattern there. And it was interesting because you could see that the places where they were, or the time slots that were not working, were actually either holidays or the weekends. But also the time slot where they were working the most was actually right before a face-to-face session, since they were asked to read a previous previously to read some material for each lesson. We could also detect that they were actually doing that at the last moment, and that was something that we were trying to avoid in this case. And you could also see some peaks of activity right before the submission of a final project, or right before a midterm that they were going to have. But besides of these kinds of just accumulative stats, we also wanted to see what they were working on, and that's the right-hand side of the screen. Many of them were working or were just accessing URLs in the browser. And then it's good to see that also, for example, these 2 bars here are related to the programming tools that they are having to use. And this, of course, changes during the course of the class, because at the beginning it's very explorative for them, so they are just checking what kind of information is out there, a lot of work or activity with the web browser, and not so much regarding the programming compiler, for example. But then at the end of the class, when I have to actually work on their final project, and they are supposed to know most of the concepts and the theory that they have been taught. You can see that this changes dramatically, and they don't browse that much. They just have to work a lot on their project, work a lot on their lessons. So it was very interesting to confirm that they had gained some kind of knowledge from web browsing, or from also the classes, of course. And they were putting that into practice with the tools that were provided. And then what I was mentioning before regarding the different characteristics of the data that you can collect, we tried to generate some automatic filters from the data that is stored in the database. Just for example, of course, there are basic filters like who the student is, or the community that the student belongs to. So if you wanted to compare two different students, it's fairly straightforward, and there's not much need to check what kind of information or what the structure of your information is in order to have that comparison. And the same applies, for example, if we remove these filters and we apply it now for the community, like try to see what classes, as a group, are working or are communicating and collaborating the most in the forum, for example. And in those cases, have some kind of intervention from the professor or the teacher in order to improve the collaboration, their communication, and try to push forward those characteristics of the class. So that was one side of the development we were doing. And then, of course, we are very probably technological biased. We try to have that connection to the class also, but since it's a programming class, it's also very technology-based. And then, so we went back to some teachers and professors from not higher education, but high schools or K-12. And of course, we now get our eyes open and very important feedback, and they are like, okay, this is very good, but at least for my context, I don't see that much of a reward or of benefit from seeing this, because it's kind of hard to understand, or cognitively it has some difficulty to understand deep visualizations. And the nice thing about, for example, GLASS was that then, based on the same data, based on the same filters, now we developed the second visualization, which was meant to be more straightforward, more very simple, just trying to, let's say, categorize and detect the students that were at the top of the activity and at the bottom of the activity. So on the top row here, you will see, of course, there are fake pictures, they are not our students, but you will see the pictures of their students and try to, well, the tool will tell you what students are generating the most of the events overall, and then based on every single type of event or tool that they are using, you could see in what range of activity level they are. So even though there could be students that are generating a lot of events, it could be because they are just working on one specific tool a lot, but they are just leaving, for example, the collaboration on one side, or if you map this to the learning outcomes of your class, for example, this student here is compiling a lot, so the work on the program is being done, but he is not using other tools that we want them also to explore. He's not browsing for new content. He is not working on that self-learning or characteristic of the student. And if he is not using other tools like a memory profiler, then you could approach them and try to improve that area in their learning. And of course, at the bottom, you will have also the students that are not working at all with any tool. They are just working a bit or checking the browser, and that is it. So our idea was to help the professor mainly to have some kind of early warning system in order to approach and have some intervention to the students. And finally, for the last visualization, this is pretty much a prototype. It's not based on the real data that we have there. But now we are actually approaching both sides or both stakeholders. This is meant mainly for the teacher, since the idea is to have an overall view of how the class is doing. But it's also meant to, we are working on a simple version of this set of visualizations in order for the student to know where he is compared to the rest of the class. So, for example, the right-hand side here will be based on exams or tests. So in this case, the student, if I was the student, I will see that I am doing way under the average. And there could be some self-reflection there that something is missing there from my point of working. And also on the other side, like trying to have some different visualizations on what kind of tools are my peers working on, how much time they are dedicating in each session to every single point of the class, how much time they are dedicating to browsing and looking for new content, how much time they are dedicating to programming, and how many issues they have been having with, in this case, programming, if they are having errors, they are fixing those errors quickly, or they are having issues. So that's pretty much the idea, to have that point of comparison and self-reflection for the students. So right now, we are working in this kind of visualization and also on the evaluation of the visualization for the students. And basically, that is it for the demo. And thank you very much, and we're happy to answer any questions you have.
I saw you had an overall graph that showed that sometimes students wait to the last minute before a face-to-face activity was going to happen, and you stated that it's something certainly we want to avoid. But was there any correlation or graphical representation looked at to see if what the correlation between their students waiting to the last minute and performance? And was that something that was considered as far as being able to represent that for the educator?
Right. That was one of the approaches, but basically, since here we are based on the visualization side and not on any kind of, let's say, statistical analysis or artificial intelligence, we also have tried with other approaches or other lines of research to find those variables that could correlate with either the final grade or the grade of the project, for example, and haven't found any specific variable that we actually correlate a lot with that. So that will be the answer, I think. But since we are based on the visualization right now, like trying to check the inside of there, and it might not correlate, for example, but it's something that you actually want the students to learn, to have a constant work rate. So still, it will be important, at least in our context, to try to avoid these kinds of behavior.
Hi. I'm impressed by all the things that you can, pull out about the students' activities. And I wonder, I'm sure that there's some correlation between the extent to which the learners are doing the right things at the right times and their learning. But I wonder if there are any analytics, there's any data that you can pull out about their actual conceptions and how they're moving over time, growing or not growing over time as they're doing these activities. I mean, I'm not, for example, using some simulator or whatever that's in there. I don't know exactly what tools they're using. But is there a way to extend this so that you can get more about what their conceptions are? I know you said that, you know, user models are hard.
Yes, thank you for the question. That was actually the idea with GLASS. Like, in that case, we are not collecting their conceptions right now about their learning or even about the tool itself. So it will have to have a data set that includes that information first, and then be able to have some either visualization of that information or try to correlate it with their performance in the class. So that depends a lot on the data that we have.
So is there any kind of data besides grades that's easy to get that would have something to do with their performance?
That's a tough question, actually, because that's what we're trying to find. Besides the grades, we're only collecting, for example, self-assessment results, and they are not included into their final grade, but we have found some kind of correlation, but it's also a test at the end, so we are not completely sure that we could use that outside of the grade. Mm-hmm.
If I may, if you have a self-assessment on a specific topic, on a specific concept, then you can, I guess. You can then know, so answer this kind of question.
Yes, you're right. The issue with the self-assessment is that in that case, in order for not being included in the grade, is also optional. So we don't have we have some kind of engagement, and that's what actually the last visualization is based on regarding the engagement here. Those are based on self-assessments on specific concepts embedded in the content. So we, more than just analyzing the performance of the student, we relate it to the engagement, because it depends a lot of if they want actually to self-assess themselves. That is what we are trying to correlate it with, more than the performance at the end. Mm-hmm.
Thank you. I think this is the end of the session. And thank you, Jerry.
Thank you.